The Raspberry Pi LED demo design has two CFS components. GPIO Live adapts the minimalistic peripheral access library so it can serve as a CFS library. It provides an interface to the Pi's memory map GPIO registers. The config.h file allows you to select your Broadcom processor chip. The GPIO demo app has two threads of execution. The main app manages the ground command and telemetry interface, and a child task controls the turning on and off of the LED. Ground commands can be sent to set the LED on and off time durations, and the JSON initialization table defines the GPIO LED control pin and the default LED on-off times. This sequence diagram shows the two main control flow scenarios. The first scenario is when the system initializes. The GPIO demo app creates a child task, and the child task constructor does a GPIO memory map. If this map is successful, it enters an infinite loop. At the top of the loop, it sets the LED pin and then delays for the on time. Then it clears the LED pin and delays for the off time, and then it repeats this indefinitely. The second scenario is for the set on and off time commands. These commands are received by the main app, which then dispatches them to the child task where it sets the appropriate values. The GPIO demo app object design is very straightforward. There's just two components. The main app manages the app initialization, the main runtime loop, and the status telemetry, and then it dispatches commands to the objects for processing. The GPIO control object manages the GPIO and LED interface. It contains a child task that turns on and off the LED, and it's the only place that calls to the GPIO Live functions are made, so that way it limits the coupling to just this object. Here's the GPIO demo app control flow. It has two parallel activities. In the main app, it first initializes, where it subscribes to the command and sends status messages. Then it creates a child task. Next, it enters an infinite loop, where it pens indefinitely for a software bus message. When it receives a message, it checks whether it's a send status. If it is, it'll send a status telemetry. If it's not, it'll check whether it's a command. Then if it is, it'll process the command. In these cases, it loops back to the beginning. And if it's neither of those, it'll send an error event and also loop back. In parallel, the child task is running. In its initialization, it reads the JSON initialization table file to get the LED pin number and also the on and off default values. Next, it maps the GPIO memory. If the memory is successful, then it will set the LED on and then suspend the task for the on time duration, and then set the LED off and suspend the task for the off duration and continue this loop indefinitely.